We now need to turn our attention closer to home and consider evidence for the age of our Earth. We study this through several different methods. These include radiometric dating, continental drift, the processes of erosion and mountain upliftment, the process of oxygen creation in our atmosphere, studies of coal formation, and within the past 15 years, through ice cores drilled down into Antarctic ice. We can look at each of these in turn. Firstly, radiometric dating is based on the observation that various radioactive minerals change over time. They give off radiation at different rates. Each mineral has a different rate of radioactive decay, and this has now been measured in laboratories for over 100 years. The time taken for half of the original material to decay is called the half-life. The rate of decay tells us the approximate age of rocks. Some skeptics have suggested that this rate of decay could have previously been much faster, and so the rocks look much older than they are. For instance, some of the oldest rocks in Greenland, like these shown on the picture, are about 3.5 billion years old, according to 5 different methods of radiometric dating. If we try to suggest that these rocks are actually about 6,000 years old, this means that we are proposing that radioactive decay used to be at least 500,000 times faster. In fact, we know that the rate of radioactive decay could not have been much faster than observed today. This is because each time radiometric decay takes place, this creates heat. Speeding up decay by 500,000 times would have turned our Earth into a ball of molten rock. Such an Earth would certainly not be suitable for life. The Bible suggests that initially there was only one continent. Science confirms this and has shown how this one continent split up into the various continents we see today. These land masses are still moving. For instance, Africa is still moving away from South America at about 5 centimeters per year. At this speed of movement, it would have taken about 160 million years for these two continents to have moved so far apart. The geological forces causing movement of continents is now well understood. Although the speed of movement can vary, this is only within narrow ranges of possibility. In other words, the study of continental drift also tells us that our Earth is billions of years old. This series of diagrams shows how the continents have slowly moved during the past 220 million years. The distribution of animals and plants also bears witness to these movements. We can divide the world into zoogeographical regions. For instance, Australia was one of the first land masses to break away. This was at a time when marsupial mammals dominated the world. Later on, these were largely replaced by placental mammals. However, placental mammals only appeared on Earth after Australia broke away. This explains why Australian wildlife is so different from that in other parts of the world. Studies of erosion and mountain upliftment also bear testimony to very long processes. The continents are largely made up of granite. This is a lighter material than the molten magma on which the continents float. We find that each tall mountain range has a corresponding root of rock below the continent. As the mountains are slowly weathered away by rain, snow, and wind, the mountains actually rise. This is one reason that we can find fossil seashells high above sea level. During the last ice age, about 12,000 years ago, much of Europe was covered with a thick layer of ice. When this ice retreated and the great weight of ice melted away, the land began to rise. It has been found that much of Europe is still slowly rising, even after 12,000 years. Clearly, these processes of land mass movement take long periods of time. Even the process of soil formation is extremely slow. All our soils come from rocks that have been slowly weathered away by rain, snow, glaciers, heat, cold, wind, and other climatic factors. On average, it takes thousands of years to create even 1 meter of soil. Another commentary on the age of our Earth is the composition of our atmosphere, here seen in a picture from space. Today it is composed of about 20% oxygen. However, the early Earth atmosphere contained very little oxygen. It was only when green plants appeared on Earth that the process of photosynthesis started producing oxygen. This process takes carbon dioxide from the air together with water from the plant's sap and uses the sun's energy to create sugars in the plant. As byproducts, the plant releases oxygen and water into the air. It can be calculated that even if the earth was covered with green plants or the seas were covered with plankton, it would still have taken millions of years for the oxygen level to rise to our present amount. It took millions of years before our atmosphere contained enough oxygen for higher life forms such as you and I to exist. Scientists who have studied how fossil coal is formed have noted various stages in this process. Vegetable matter needs to fall into an oxygen-scarce environment, such as in a swamp, where it turns to peat. After burial, pressure and heat, this peat slowly changes, first into lignite, and then into bituminous coal, and finally to anthracite coal. It is a very long process of compression and heat until finally coal is formed. Botanical studies of material in coal show many layers of different vegetation representing changes in climate and vegetation types, and it takes an enormous amount of compressed vegetation to form a few centimeters of coal. Some coal layers are many meters thick, as seen here when compared with the truck in the picture. This has to represent a very long period of plant material accumulation. We can also see several layers of coal separated by other deposits. One brief catastrophic event, such as a flood, cannot explain all the different types of coal, the thickness of some coal seams, and the existence of numerous seams above each other. These deposits were laid down over many millions of years. Within the past 15 to 20 years, scientists have been drilling down through Antarctic ice. They extract a continuous core of ice and store it in vast cauldrons. They have now drilled down through accumulated ice to layers that were deposited at least 800,000 years back. This age is determined by counting the number of summer and winter deposits. These are shown up as layers in the ice. Analysis of tiny air pockets trapped in these extracted ice cores has enabled us to discover changes in air composition over the centuries. However, even more fascinating is the discovery that Antarctic rocks, far older than the 800,000 years of accumulated ice, contain fossils of amphibians and other animals. These creatures lived and died more than 800,000 years back. In fact, the rocks containing the fossils are millions of years old. When we combine all these different lines of evidence, it becomes clear to most people that our Earth is billions of years old, not just a few thousand. The challenge facing people who accept that we are the result of the creative wisdom of God is to harmonize revelations about Him in Scripture with revelations about Him from our scientific studies of the universe that He has made. The voice of God speaking to us from the discoveries of science expects us to give an answer. Are we prepared to study these new revelations with an open mind, or are we going to close our minds and stick rigidly to traditional interpretations of the Bible? Those of us who are prepared to open our minds to new revelations will discover that it is possible to reconcile all these scientific discoveries with our belief in the Creator. May I remind you that much more detailed discussions of these subjects is available from my webpage, factandfaith.co.za. This gives extensive free downloads and information about my books on these subjects.